Good morning, good evening, good day, good eye. Hello, bonjour, good day. What else? Buenos días, bienvenidos todos. Welcome. My name is Caroline from Bubbling Maths, and I present these videos daily on the Making Maths Fun for kids of all ages, except Sunday morning. And this session is intended for 7 to 18-year-olds. Now that seems like a very wide range, but that's because the activities that AIMSEC provide on the Aiming High website, they are low threshold, high ceiling activities. And because of that, they're achievable at a low attainment level, and they'll stretch anyone from the lower level, age 7 level, to 18 and greater. They're entertaining, engaging, enjoyable activities, and I'm just having a look now. I just want to share the live that we're doing so that other people can join in with us. Here we go. And here we are. Just pausing for 1 second, engage brain and start. Yes, I think I managed to engage brain. Fingers crossed that I managed to engage brain. Okay, now the other place that I just need to open a document so that I can show you this. So I could just show you this screen. It'll be all right on this screen, I think, I hope. Right, okay, so welcome. And we're talking about Durer's magic square. Well, Durer's magic square, it's not just any magic square. If you haven't encountered magic squares, they are exciting and extraordinary. We're going to investigate this one. We're just going to do some investigation. So I'll start off with the visualizer. So hold on to your britches, because this is going to be hopefully something quite special. Seems, here we go, share. No, not that one, share that one. That's it, that's it, that's it, that's it. Okay. So that doesn't look very exciting at all, does it? Not at all exciting until we start. Now this, as I say, this is for age 7 to, this is one of the 7 to 120 activities. So I'm going to, let me make sure I can see what I'm doing. Okay, we're going to go 1, 2, 3. Go ahead and draw what I'm drawing. Today we don't need anything complicated. Just a pen, paper, and a brain. That would be helpful. So we can switch on our brains. Switch on our brains so that our brains are open. And hopefully you do a better job of drawing than I do. And you know what? I'm okay with not being the best at drawing or the best at anything. My priority is to get the job done, to learn. And let me see what else I wanted to say is, yes, in the description, there is a link to the resource, to the activity. So please do feel free to download that and print that. On that resource, there are blank squares like this, blank 16 4x4 squares, matrices, whatever you want to call them. There are lots of them. You can draw what I'm drawing. So it's in here, we've got every number. It's kind of like a Sudoku, but instead of only going up to 12, it goes up to, what number does it go up to? You tell me what number. It goes between what number and what number. It includes all the numbers from 1 to 16. Okay, so this is our first investigation. I'd like you to add all the numbers across that top row and tell me what they come to. I'm going to do it over here. I'm going to do it in my head because I find that can be quite good practice. I'm adding, what I'm doing is I'm adding the 10 from there and the 10 from there, that makes 20, and the 6 from there and the 6 from there, that makes 29, and then an extra 5, so that's, I make it. Okay. Now what about the next row? Add all those together. You ready? All right, now what about the next one? Oh, if you know your numbers bonds to 15, you'll know that 9 and 6 are 15, and that's a really good thing to practice, is your number bonds to 15. So I've got that as 15. Oh, no way. Surely not. You got it? You got the answer? What do you think the next one's going to be? We'd better check it. Let's see. 15, I say that's 15 plus 15 minus 1, so that's 30. I know 15, 2 15s are 30. Take away 1, that's 29. And what do you think it is? Okay, this is interesting. What about the columns? We've got all the rows add up to 34. What about the columns? Let's add them all up. I'm doing the 10s again here. 10 and 10, 20, 2 and 3 are 5. That's how I'm doing it. Whoops. And just double check that you keep working on those. You just keep adding those up, and I'm just going to do some trickery pokery. Make sure that you're actually seeing what you're supposed to be seeing. So I haven't been able to double check that yet. This does not bode well. Let me see. It's very confusing. Right. If someone could let me know what's happening here. It appears to have stopped. Right. Okay, I'll start it again. Thanks. Right. What do we do here? Unplug it and plug it back in. Ah, okay. Now. That will continue playing it. Well, is it working? Okay, it's working. So I'm not sure if that's me or Zoom. Well, I know it's not me, but is it, which technology is it? Which part of this technology has done that? I don't know. Right, you've got, okay, you're now up to date. You're now as far as I am. So keep adding those columns and see what you come up with. Hello, Barbara. Hello. Do you know, your clown name's not coming to me, Lee. I'm coming up with Lee, and I know I never call you Lee. I didn't even add those. I just wrote them out. I better check them, hadn't I? Just double check that you can see what I can see here. Okay, it's very spotty, isn't it? It's not smooth at all. Okay, so that's 31, ooh, 34, 9 and 15 is 25, and 30, and yes, again, 34. Now we're going to do the diagonals. 26, 27, and 7 is 34. And that way. What are we going to go that way? So this is great addition practice, but don't just write in 34. You do have to do the work. And 24, add 10, you've got 24 adding those two, that's 10, so that's 34. Now, that is what you call normally a number square. Okay, now let's see what else we can do. What if, looking at that number square, we now go and it's a magic square, so it's called a magic square, right? So we're going to go with this design. Let's see if you see it. Come on, catch up with us. Catch up with us. Now I'm going to get another colour pen. And go with red to make sure you can see it. I want you to add 4 numbers in the 4 corners. Add those numbers together. And what does that give us? I also want you to add 4 numbers in the inner square. What does that give us? Now this is too weird. So the activity is to find all the patterns, if you possibly can, and it's okay if you don't find them all, but you want to find as many patterns as possible that give you the same answer. Now, just one little word here. I'm going to just double check, see if I find what I'm looking for. Make sure I get this bit right, because I don't want to lead you down the wrong path. I'm going to draw another one, and this is a hint as well. So look for all the kind of squares, all kind of rectangles that you can find. But there's more. There's more than just squares and rectangles. There's way more. And here's a hint, but in addition to this one, there's more. When you think you've found them all, there's more combinations, and we're looking for patterns. So we've got this, 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 and this, making a parallelogram, and likewise this, 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 and this, whoopsie, make a parallelogram. Add those up there, and there's all kinds of different patterns that add up to 34. Now, I'm going to actually leap ahead because there's something else. So here we are adding numbers in a number square. And just to give you a bit of background about this, I'm going to stop sharing that one and start sharing this one. Hello. Oh, I don't know why you give me that. I'm really not interested in seeing that. I just want to actually share the screen. Thank you. Now, this is called Durer's magic square. And the reason why it's called Durer's magic square, it's not just a magic square, it's called a super magic square because it's got so many, very many points where you add 4 points together and it makes 34. Oops, I don't want that, thank you. So we're looking for 10 samples, by the way, for where you're going to find the different shapes that add up to 34. But the reason why it's called Durer's supermagic square is he made this engraving. So clearly he'd done a lot of work on it. He made this engraving called Melancholia. This is from 1554. You see that there? 1554. How many years ago was that? More than 500 years ago. This man had been working on this magic square, and here it is right here on the wall in this man's office, his man's lab. He looks like a scientist. Look, he's got scales, he's got a timepiece there, he's got a bell that rings. That's, I don't know what that's all. Look, he's got a compass, he's got this geometric shape here. He is, oh, look at that. That's a symbol of enlightenment. Rainbow there. But there's a sphere there. I don't know what else there is. If you look in detail with a high quality image of it, I'm sure you'll find lots and lots and lots of things. And here's another one down here. This is in the resource. When you print it out or just download it, you'll find it. This is another example of Durer's magic square, but it's different. It's ever so slightly different. So it'd be interesting to see what's the difference between the magic square that we just looked at and this one here. So see if you can see what's the same and what's different about this magic square that was found on a seat in a school in Denmark. So the next thing to do is, when you've found all the patterns, if you find them all, so there's another 2 example. If you put them all in one sheet, here we go. Here's the, wait a minute, I'm going to go zoom down to the blank sheets. That's the ones you can print out to help you. And now we're going to look at some of the solutions. They are here, but please don't use them to see if you can find them for yourself. But the reason why I'm going to show you this is we also want to find the symmetries. So we want to find which of these shapes has, we're looking for, this is now for the older learners. So we can find just mirror symmetries for primary learners. And then we're going up to lower secondary and upper secondary. We want to find all the different symmetries. And we've got rotational symmetry order 4, which means it goes all the way around and comes back to itself, but it can rotate. We're looking for rotational, order 4, apologies, means it rotate 1, 2, 3, 4. That's rotational symmetry order 4. Rotational symmetry order 2 is you've got that way and that way, it's the same. And the mirror symmetry means it's the same on either side of a mirror. And then we've got reflection symmetry in the vertical and the horizontal axes, which is the one that primary school children will be familiar with. And then we've got reflectional symmetry in the diagonal axis. So on the diagonal, we've got reflectional symmetry. We're looking for all of those. Now these are the answers. That's what we're looking for. I'm not going to show you that anymore. And don't look at it again. You've seen it. You know what you're looking for. See if you can find them all without looking at that resource. And what's great about it, it's rich, it's fun, it's, oh my goodness, how on earth can it be possible? So really you need to, well, I feel the need to actually do them all just so I can confirm that it is possible. And in the resource you do have you can download in the activity sheet, you can download all the squares, you don't have to draw them out, but it wasn't that hard to draw them out, was it? And I'm going to double check that we're still working. I hope so. Okay, I've got a question. This is brilliant. Spotty, Spotty, I remembered, Spotty. Okay, hello, Spotty. Now, which numbers to start with? You don't know which numbers to start with, Spotty. You simply have a go. Well, I gave you the first hint. You go with the big square on the outside. We did all the lines. We did all the rows, the horizontals. We did all the verticals. And then we did the diagonals. And then we started looking for other patterns. And it doesn't matter what, as long as you've got the 4 points, you're adding. It doesn't matter what order you add in. So that's the point. You don't know which number to start with. You just have a go and find a spot and see if you can find a rectangle, a parallelogram, even, and this is a hint, even a kite. There's a kite in there somewhere as well. Just one example of a kite. So they're all quadrilaterals, because the whole point is that it's 4 numbers. It's 4 numbers that make up to 34. So they're all quadrilaterals. So find all the quadrilaterals that make up to 34. And that's the task. And then, so what is it? What are the learnings from it? It's suitable for younger people to practice addition, and then for older learners, giving them the investigation, looking for all the quadrilaterals and all the symmetries, and talking about it and discussing it and making sure you've found them all. And the best way is to not look at the solutions. You've seen that there's lots of them. You've got an idea what it looks like. Now go ahead and find them yourself. And what you're doing is you're learning how to be flexible in your thinking. You're being a little bit brave, like Spotty. You're just going ahead and experimenting. We call it manipulation. We call it just playing with it until you find the options. And when you do find a new one, that is when you get excited. And then that's your incentive to go and find another one. And we are looking for a couple, at least 2 on each of each square, because we're also looking for the symmetries, and the symmetries will come with doing more than one. And let's see what else we've got. You have your visualization, you're visualizing and interpreting, you're creating visual images to find a concept. So you're finding a parallelogram at the same time as adding 4 numbers together, and you're looking for the symmetry, and making it a very visual, doing something in your head to make it real. And then you're going to evaluate what you found. You're selecting, organizing, analyzing, and interpreting information. And all of those things you can do. If you're 5, you can do it at one level. And if you're 18, you can do it at a much broader level. So, and yes, and then we've got some suggestions for grown-ups to help guide. There's a lot of suggestions in there for grown-ups to help guide in the home learning guide, which is on the page where the link is at the top in the description. So, yeah, and the rest is you can just print out the blank squares that are provided for you if you prefer to do that rather than to draw them out. So if you are, thank you for watching. If you are enjoying these videos, these daily lives, please do share them. Please do share them with your friends, share them on your page. And if you really like the group, Making Maths Fun for Kids of All Ages, please also share that, tell people about the group and encourage them to join. That would be marvelous. The idea that we're here to help people with their home learning. We're also, the reason we have these wonderful resources is they come from an organization in Africa called AIMSEC, and they've created this website called Aiming High with all the resources, which was originally intended to support the teachers, because what they do is they provide high quality professional development for teachers in Africa that work in rural and disadvantaged areas. The quality of the courses is equal, second to none, so it's great. They're great courses for people from all walks of life. and all the resources are created so that people in rural and disadvantaged areas can apply them in their classrooms, which means that they are easy to use. They've got the resources of things you have at home: paper, pencils, rulers, a pair of compasses is useful, and lots of scrap equipment, sticky tape, string, and lots of scrap paper. And and then what we do at Bubbly Maths is we support AIMSEC. That's our way of giving back, and they're supporting us now. We're supporting each other by providing these lives every day, and this will continue. This is not going to end when the lockdowns end. We're going to continue having started. We're just going to continue doing lives to support anyone learning at home or teachers that work in remote areas where the extra support would be helpful. So please do share this, and also if you have a YouTube channel, please, if you seem to have a YouTube account, please subscribe to our YouTube channels, which are Bubbly Maths, where we upload all these lives, and Maths Toys, where we're creating videos specifically to support. Each resource will have, at the moment, one video, and we're also going to add an early years video to many of the resources that are on the Aiming High website. So thank you for joining us. Let me have another look, see who else has joined us on the live. So we've had, you're welcome, Spotty. Andy, there's another clown called Andy the Clown, and Russell. Andy the Clown can do something that Mr. Tumbles can do. He can sign. I don't know very many signs. I can say thank you, Andy. And John Cooper. He's Frosty the Clown. Well, he's very frosty. And Melissa, hello, Melissa. Thank you for joining us. Oh, and Helen Dodd, hello, Helen. We still have to talk about bubbles, don't we? And then on the other one, if you've joined us in the actual group as opposed to the watch party, the comments don't come up until afterwards, so I will check the comments and I will respond to any comments that you've made. And thank you for making me aware that it had stopped, Spotty. That was, well, it's working now. Thank you very much, and I will, the 10 o'clock is the next one. That's for early years at 10, that's in 33 minutes from now. That's 10 o'clock London time. You can always watch it in the replay. And then 8 o'clock tonight, I'll be sharing what we're going to do tomorrow. Now, tomorrow and Thursday will be reruns because I will be working, doing something else tomorrow. I won't be here available to do the lives. And we're going to choose the best of the best. So do join us for watch parties of the reruns of the best of the best reruns. So I'm sure you will enjoy it. Thank you very much. And now I've got to do the eternal search for the stop button. There we go. Thank you. See you later.